Hello, Year 9. So today we're going to take a look at how you can find the volume of cylinders. Cylinders are actually just prisms, and here's why. Prisms are defined as having a lateral face that's a rectangle, and in this case, the lateral face is sides. So think of like if you have lateral abs, you're doing a lateral ab routine. You're working on your sides of your abs. So lateral faces of solids are the side faces. So in this case, it's the one that I'm kind of going around with my pen. So the way you know it's prism is if its lateral face, or this one, is a rectangle. And actually think about it like this. Picture this as a soup can and I were to cut the label. Or sometimes you've done this before with a water bottle, you take the label off and you unravel it. If I were to unravel that lateral face, wouldn't it just make one really big rectangle? Pretty cool, right? So this is actually a prism. And why that's important is the way you find the volume of a prism is you just find the area of the front face. But in this case, the front face is the top one here, which is a circle. And then you usually would times by the depth of the prism. But in this case, for a cylinder, we just times by the height, which is the depth. So step one, we need to find the area of a circle. Now this is what we did last week, so hopefully this is fresh in your minds. And the area of a circle is pi times radius squared. In this case, the full diameter is 500 centimeters, so we actually only want what the radius is, and the radius, don't forget, is from center to outside. So if you ever get the diameter, we just half that, so that would be 250 centimeters to get the radius. And now I just plug that in. So area equals 250 squared times pi. This is something you can plug into your calculator. If you ever see something like this, rounding answers to one decimal place, that screams that you're going to probably be needing a calculator. So 250 squared in your calculator times pi. Did you get something like this? I got 196,349.5408, which is looking at about 196,349 centimeters squared, since it's area. Now to get the volume, last step, all we do is we take this value here and we times by the depth of the prism, or the cylinder in this case, we have to times by its height. So I would take this number, 196,349.5408, and we multiply it by the height of the cylinder. Now, once you plug this into your calculator, notice we are going to get more than one decimal place, so be careful and start thinking about how you're going to round that value. So here's the number we get, 2552544.031. 2, 3, 1, 2, so that's 2 million. Wow, it's a large number. And then to one decimal place, would that 3 round up or down? We'd round it down, so actually it'd be 0.0, wouldn't it? So we'd get 2,552,544.0, and now we're in centimeters cubed because we're in 3 dimensions. Volume would be the 3-dimensional space. All right, so if you'd like to take a second and pause the video, that's fine. So you can kind of take that all in. When you're ready, can you please try and find me the volume of this cylinder here? So can you please take a second and find this volume? All right, let's see if you got it right. So we know the first thing we do is we find the area of the circle. And in this case, they gave us the radius, so we can plug it right in. So volume equals the area times the height. So area of the front face will come up here, is in this case 3 squared times pi, which would be 9 times pi. And let's see what you got for that. So calculator ready, 9 times pi. Hopefully you got 28.2743338. That's what's on my calculator. And then all we have to do is take the area of the front face, or the circle, and times by the height of the cylinder, which is 7. So all we have to do to get the volume is take that 28 number, 3388, and we multiply it by 7. Now, you type this into your calculator and you round it to one decimal place. Did you get this value here? I really hope you did. If that makes sense, hopefully this will help get your Heggetty going. If it doesn't, again, please Try to watch the Heggerty video as well. Mr. Heggerty might explain it a little bit differently. Maybe it'll be a little more helpful. Otherwise, feel free to shoot me an email. I'm happy to help in a different way if that's helpful.